This is a very small portion of this chapter, that is velocity selector. Now, from the name itself, it's clear that it's a device which is selecting a particular velocity. Now, we are discussing the theory behind this working of velocity selector. Here we are using two fields, uniform electric field and uniform magnetic field, which are mutually perpendicular to each other. Okay? So, suppose I have a uniform electric field acting on the plane of the ball, which is vertically downward, and a uniform magnetic field B is acting perpendicular to this electric field, which is into the plane of the ball. So this magnetic field is actually into the plane of the ball, going into. Now, from this region, if I project positively charged particles, different types, into this particular region, then we can find that some particles are going up and some downward, and only a few particles are going through the fields without any deviation. Many particles are projected, few of them are going up or turning to upward direction, and few of them are deviating downward, but a very few particles are found to be moving straight without any deviation. Now, if you check the particles, you can find that those particles are identical and also they are having a definite constant velocity. So, out of the group, now we are getting only a selected few with a constant velocity. Now, how this is possible? Let us see. Why some of the particles are going up and some are going down. Let us see. If positively charged particles are entering into this field, electric field will be acting downward, and therefore there will be an electric force acting, that is Q into E. This is the electric force acting. Electric Lorentz force acting. Now this electric Lorentz force will be influencing the positively charged particle, and that will make the particle to go down. But at the same time, there will be magnetic force also acting on it. And you can find the direction of the force by applying left hand rule. Positively charged particle going. Field is into the plane, and therefore the force will be directing upward. So some of the particles are found to be moving up because of the magnetic Lorentz force. Let us see. Magnetic Lorentz force, Fn, that is equal to Q into B cross B. These are the two forces acting on the particles. Now, those particles which are influenced by a large value of electric force will be turning downward, and those particles which are influenced mostly by the magnetic field will be going up. But a very few will be going straight onwards the effect due to the electric force and the effect due to the magnetic force which are balancing. That means Fe will be equal to Fm for those particles which are getting selected with a constant velocity. Now, using this condition, we can have Q into E is equal to Q into V cross V. This is the formula. But you can see here the speed of entry and the direction of the magnetic field are perpendicular to each other. That means V and V are perpendicular in this case. Therefore, I can write Q into E equal to Q into V into V, the maximum. And therefore, from this one I get the velocity V will be equal to E by V. Now this is the equation for velocity set. So what actually happens there in the case we understood. In the case where the magnetic and electric forces are equalizing, those particles are found to be moving straight without any deviation. And therefore we get a condition like this. And here you can get one more condition that electric field E is equal to V into V. This condition is also possible. This you will be applying somewhere in problems. Sometimes you will be using that also. Okay, so this equation is very, very important. This known as velocity selector. That is all.